Okay, hopefully we've solved all the audio craziness. Let's just go over to Twitch and see.
Pony's gonna start jumping.
Hines. Hey, can you hear me? Hey, can you hear me? Yeah, that sounds pretty good. Okay, so you can see from the Twitch stream that we've added a few things. We're gonna start using Accomplice for like real-time goal tracking. So the button on the bottom left is it's a little tiny Accomplice window. I really encourage you to check out the Accomplice app and check out the author of it, Malcolm Ocean, on Twitter. He's a cool dude, very smart, very knowledgeable on like productivity, metacognition, these sorts of things. So yeah, we're gonna basically be using this to track what I'm working on at any given moment. So today's task is we're gonna respond to all of the MR comments. I'm gonna append some text. Actually, what's cool about Accomplice is you cannot change the text of a goal. You can only append to it. So you have to be kind of careful. Looks kind of terrible. Go back over here. Accomplice. There we go. That look better? Yeah, that looks better. All right. So let's dive in. We're gonna open up the MR in our browser, and we're just gonna go through these comments one at a time and see what people have to say. Try to address it the best we can. Okay, so let's open up Rome actually. Stream. We're gonna use a stream template, and we're gonna say we're gonna leave it untitled for now. Who knows what's gonna happen? And there's no upload yet, so yeah, our objective, I don't know, is complete all these MRs. How long do we think it's gonna take us? Oh, complete resolve. This is a terrible name. Resolve MR comments. There we go. How long do we think it's gonna take us? Let's know what kind of comments there are. Tell you what, let's look through each of them. And you know what? Let's make estimations like one by one. I don't know. Let's make estimations as we go through it. I don't have enough data yet. I have 2 points. This is what YRG says. I have 2 points that need actions from your side. Design must be discussed a bit more. I have 3 main points here. 1, I do not understand why we want to reject registering a value with constants if it does not introduce cycles. B, the concrete syntax seems a bit inelegant. True. C, the Tezos client's interface has to be specified, I think is what he meant. 2, it's hard to properly review a draft because we need to be able to test your code manually, especially dark corners. Please, quote, make it work. We'll refine the code from there. For this one, let's follow make it work, make it right, make it fast, make it beautiful. Yeah, this quote, this is a very interesting way of phrasing the quote. This is like something we should ask him about because oops. The actual quote, if I know it, is make it work, make it beautiful. Like, I looked this up recently. I was like, oh, this thing. Like, this is a good article on it. Make it work, make it beautiful, make it fast. Ooh, okay, Tom Harrison Jr. Make it work, make it right, make it fast. Repeated to Kent Beck. Okay, I think this wiki is awesome. This is kind of like a this is the spirit of Rome for sure. First crank out code that handles all common cases. Then fix all the special cases, error handling instead of so all test pass, make it right. Or clear. Refactor, make it work. It's part of getting the code to operate correctly. No. Yeah. So, listener, really interesting point. Point on, quote. But so Mr. Who is this? Kent Beck is equating good design with moral correctness. That's something interesting to talk about some other time. Global optimization is making good design choices that become very difficult to change after you've made such decisions. They pervade your code base. Right. Fast an assertion that if you can make it right, you'll be able to make it fast later. You won't need to do any global optimization. Local. Only those times when you can't make it right. Design. Of time. A rabbit. Oh no, viewer, I forgot to switch streams. Anyway, Wiki is like, wow. This is kind of mind-blowing, but, and like, I don't know how to process it all. So we're just not going to. Of, responding to the LMR comments. And we're going to start our Pomodoro timer, actually. So we're going to work for 25 minutes, then take a 5-minute break. Okay, so, let's see. We're gonna skip YRG's comment real quick. Go over to here, Bjorn's thing. What's the reason for forcing the computation? Oops, I keep forgetting to switch the stream inputs. Okay, there you go. Now you should see it. What's the reason for forcing the computation, then lifting it to an LW2 again? LW main run. We'll set up a new scheduler. Also, Why do you need to fail fast? I believe just mapping over the results, raise on error, would do in that case. Is that true? I don't know. Let's look at the code. Let's test it. What Joel is saying is all wrong. Maybe that's true. When I first wrote that, good how to use LWT, because nobody told me, oh, Daniel, it's just JavaScript with infix operators. Like, I mean, people said, oh yeah, it's promises, but like it didn't sink in that it's literally just promises. And then with these like fancy symbols, like once I checked out the like error monad operators, and once I figured out that they all lived here, like LWT was like, all right, we can work with it. So let's look at his assertion. His assertion is that this force function is the same as like, you know, foo and then maybe like find function like maybe okay, like let x equal foo okay x blah and then error raise, you know, let's just do assert false. Okay, like let's do LWT dot return okay unit. Okay. Why is this unhappy? I don't know. Let's not be fancy. Let's just use fun x match x with. Still not happy. Oh, because there we go. Oh, I hate that autumn format break, like puts it all in one line. Terrible. I know there's a way to fix it. But like it requires changing source code and I don't want to have to do that on every time I'm working with it. Okay, audience. The choice. We have a choice. We can test exactly how this works. But this is kind of like a global problem. Like LWT swallows up stack traces, makes it quite difficult to debug. But in the time that, you know, since I initially wrote this code, I've gained a much better understanding how the error monad works. I can manipulate it much better. So you know what? I think, for the sake of being at peace with all men, as much as depends on us, we're just gonna refactor this out of here. Job Joe. That is such a cool I love that handle. Job Joe. We're just gonna get rid of force global, and we're gonna get rid of force, and it's gonna be fine. Like, let's estimate how long it's gonna take. Okay. Like, I don't think it's gonna take long. So to help us estimate, we're going to cd into the thing and test. And we're going to comment out all of the tests that we don't need, because I don't remember the command to only test the things that I need. Oh, maybe it's in Vim, or maybe it's in my profile. Dune build run test. Okay. So I have a run test alias. I don't have thing for testing just the things that I need to test. So like in the future, like let's see, quality of life. Figure out how to test specific tests. Like it's in, oh wait, and add bash alias for it because it's probably in the TZFAQ, but I don't want to mess with that right now. So instead, what we're going to do is we're going to go to main. We're going to comment out all of the tests except for these ones. And then we're going to try the run test alias. Okay. And now we're going to get rid of all this stuff. And we're going to see what make tells us. Okay. Problems. All right, there's only 7 problems. 7 places. So if we allot 2 minutes per thing, it's 15 minutes. I'm gonna this is probably wrong, but I'm gonna say it. We're gonna go ahead and make like an estimation block from templates estimate, and we're gonna say like estimate actual. Okay. Yeah, I like that. I like that a lot. Let's go to the daily notes. Okay, so we're gonna type in estimate. How long to replace force with proper LWT stuff? Like this doesn't quite work. So let's fix it to be like, maybe the estimate is like 15. We're gonna give it in like hours, minutes. And actual is unfinished, and we're gonna change this to like estimation. Okay, and let's go back to our template. Change that as well, because I kind of like that better. Like estimation, and then there's a slot for the estimate and a slot for the actual. Okay. And how much time do we have on our Pomodoro timer? Like 13, 13 and a half minutes. So like we'll be pretty close if we start the 15 minutes now. So let's try it. Let's see how long it takes to replace LWT or like force with 2 minutes per thing. Starting now. Okay. So just going to first say this. One. Where's the context? Context. Fun context. 3. There's 1. There's 2. Okay. Fun context hash. Okay. Uh. This is unhappy. Oh. Okay. So, viewer, there's a problem. So I didn't look carefully at the close of this thing, but this thing yields a result. And I'm using a thing that takes in a result promise, lwt.t. We're just going to call lwt.t promise, okay? And so, there's a mismatch here. Fortunately, discovered the error monad thing. So we're just going to look at these until we find a thing that is like the right type. So a thing from like result to like it'll hopefully like lift it to the right type. Is this it? That wasn't it. Let's see. Let's do this. Let's do it this way. Okay. Error monad dot. What about this one? Takes in. Oh, let's look at this one. This takes in a result and a function. Yeah, I think it's this one. No. What was it? I lost it already. Error monad dot. Okay, so it's bracket question mark equals. So bracket question mark equals. Hey, that looks. Why isn't that right? Like, is there some other problem? Is this like a problem of parentheses or something? Syntax error, line 55. Why is this unhappy? Oh, I deleted an in, I think. Oh, maybe it's something like this. What is this yield? Unbe. There we go. Wait. Oh, this is some kind of like I'm using the wrong operator somewhere. Okay, I'm fumbling all over myself here. What's our time at? Let's see. I started this I think at the like 11:50 minutes. So this is 5 minutes. And so hopefully we can still make it, but we've got to fix this one. All right, so let's be methodical about it. Right. Up, up, up. Assert false. Let. Okay. Okay, we'll come back to this one in a second. Let's see if we can fix all the other ones and then try to meet our deadline. Okay. This one's easy. Fun, context, boom. Easy. Like, we could have like an automated refactoring tool that could do this. But, like, why? This was a dumb thing to say. Um, oh no. Okay, I think I know what to do. Environment, not like, yes, yes. Sometimes like, we have trouble converting between like the OCaml error and the like Tezos error. And so if you just pop this like this magic incantation here, like map thing through this environment.reptz result function, it works. So here, okay, 7. Go here. We can fix a bunch of them. This one. Fun. Context. Fun. Oh, this is the same like thing. So what we're gonna do, I've got this. So we're gonna say LWT dot return this thing, and then we're gonna map it to this thing. Why didn't that work? Tell you what, we're gonna map it to assert false. I'm surprised this didn't work, to be honest. Oh. I think I got it. Boop, boop, boop. Environment dot FTZ result. Okay. There we go. All right. Down to 4 problems. Okay. Same deal. Fun. Context. Boop. Monad. Read. Okay, there we go. Ugh, the same deal. Fun. Hash. Hey, this worked. Okay. Oh boy, we're getting real close. Fun. Why? Why is this unhappy? Is this one of those? Okay. All right. We fixed it. We have 4 minutes to get rid of false. Get rid of like 5 falses. Or maybe like 4. 3. Do it. Okay, this assert unchanged function is going to a context. And it's going to take an LWT.return at this one. And we're gonna map it to, got a few more minutes. Okay. We're gonna map it to fun. No, context hash. Let's try the thing. Environment result. Yeah, there we go. Is this like another one of these? Oh my goodness, like why do we always need that? I'm not sure. But we do. And it's not what we're gonna worry about at this exact moment. Okay. It falls. We've basically missed our deadline, but we're gonna be real close. But I'm not gonna say that. Let's see. Is this working? I think it's working. Okay. So was that the whole problem with this? Like, because really, I expected this to work. So if we do like the type of this thing is um is there a nice way to do this? Let's see. Error monad okay, I take in a result and a function from A to the error monad thing. And return the error monad thing. Whereas wrap TZ result is a function that just kind of converts one to the other. Okay, so let's just start with this. All right, this expression has type error monad result equals really? Oh. Forgot the so like that. All right. This type has an expression. Okay, so we've definitely missed the deadline, but let's see. Environment.wrap to result. Dang. This expression has type Dang. Okay, you know what? There are more important things to do, like error monad wins today. There's some right combination of like monad combinators, and I don't know what it is, but I know that this works. Find it there, and that, then boom. That works. So let's review. Did I like add any assert false stuff? Assert false, that shouldn't be there. That's okay. That's okay. Only two. Great. Okay. Refactor successful. How long did that take? I wish I'd recorded the end time, because like the current time is 14:10, and I think I that took 20 minutes. So like 00:20. Yeah, it'd be cool to like, automatically, calculate that difference. Um Maybe like, I don't know, it's good enough for now. We'll figure it out. So I was, off by 25. I said 15 minutes, it took 20 minutes. Like that's sad because it's just really simple. But at least I was close in my estimate, and we can get better with the error monad. That's like a doable thing. So let's just upload this and be done with it. Do these changes. We deleted all this stuff. We switched out to like the error monad. Proto remove force from GTOC tests. Great. As soon as the linter finishes checking this, upload it. Real slow. But I think it got it. Uh-oh. Did I commit too much? Yes. Did. Undo last commit. Like dash this. There we go. Oh my goodness, this is taking too long. Quality of life. The pre-commit hook takes way too long. Like, yeah. I mean, I don't know a better way to do it, but I do know that it feels slow. So we're gonna upload this. And we're gonna say point wasn't yet very familiar with how to use the error monad module when I wrote this. I have refactored out the use of force from these tests. Add comment now. applications. Just say the pipeline failed. You know what? One thing at a time. Our job is to do these comments. We've put 1 tomato on this thing so far. Okay. Resolve this threat. So we're going to toggle it. Okay. YRG says this seems to validate the point that we only need 1 constructor for constants. Why did I do this? Why did I use 3 constructors? Can't remember. Like, the concrete reason is that GA said create 3 constructors. But I don't know if that was like necessary or just kind of accidental. So we'll talk about it. Okay, rather than forcing the promise and assert test with assert, I believe you could do assert equal turns in the LWT context. Talking about assert blah blah blah, and he wants me to use assert equal instead. Let's try it, folks. Test global constants. Assert star equals. Here we go. How many places do I use this? 2. Okay. 2. Assert equal. Are there other places that we can find using this? Are there like doc strings for this or something? What is this equality function? Oh, it's actually just like structural equality. That's nice. Okay, and then printer. Okay. If not equal, then fail. Wait. What? This is not the same function. Because yeah, this is it. This is it. Else return unit. Okay. If not, pair. Like we'll just pass in structural equality there. Then fail with okay, a message, pretty print A, pretty print B. Got it. Okay. What is this? We need a Michelson pretty printer. But I have one, I think. Let's see. Michels Michelin printer dot p no. Michelin dot p. I don't know. Right, assert equal location. That's probably like location. Oh, I know it's one of these. Lock. Lock. There we go. No? Oh. Lock. Equal. Maybe like equal. Maybe I don't know. Ooh. Empty string or like a random string for now. So it's of type format.formatter a unit. So we need some kind of like Michelin printer dot. This is it. Let's see. Michelson. Let's try. I think we were close. Michelson v1 printer dot. That worked. Oh, why is it unhappy? Line 75. Huh. Okay. Oh. Oh. Yep. This thing is like map. But like, if there's an error, just return the error. If there's not an error, map the result with this function. Oh, I think this is working. Okay. We need some kind of expr from string. We gotta comment out this. Yeah. There we go. Look at that. It worked. Okay. Okay, we're gonna name this like let assert equal. Oh. Okay. Assert expert equal. Um. Expert equals result expert. Okay. So like equal expert result expert. Boom. Yeah. Assert expert equal expected result expert. Oh, but there's a problem. We need to like find like this thing. And now we need to test that this works because I'm not sure. So let's replace result expert with like expert from string unit. This thing a little comment out there. Now we should see like line 91 as the problem. Line 91. Boom. Got it. Is Accomplice still tracking? Ah. Okay, Accomplice is still tracking. Good, 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 good. Okay. So, great. We did it. Assert.star equals use nowhere. So perfect. Let's like commit this. Let's stash this again. I should have just popped the stash before. Oh no. Stash pop latest stash. Okay, we can just delete this because we have it in stash. Proto use cert equal in UCOC test. Another good point. Control. Thanks. I've refactored to use this instead. Resolve thread, add comment, upload. Done. Rocking and rolling. Given that the value, okay, let's moving on. Given that the, oh, gotta show you my screen. Given that the value you are substituting substituted into large, I think we cannot try to iterate it over it using a monadic computation. Instead, you should probably decompose the process into 3 steps. Iterate over the value to retrieve all constants it uses. Write this outside the monad. Put the constants in a set to avoid repetition. Bold over this set of constants. Build a hash map from constant hashes to values. Oh boy. Like, that will, like, I could probably figure this out, but it also sounds like I could get it wrong. So we're gonna skip this one and come back to it. I want to discuss this design choice, but in the TZIP. Fails with value itself into reference. Essentially a magic number. I noticed the above, the cases similar, this one simply incremented previous case number. So I did the same. Ideally, this would be handled by some kind of code, like meta programming, that checked, that ensured the correct number, and in a backward way. But for now, we just have to stare at it and make sure it's right. Okay. Oh, we're almost there. Okay. All right, let's read all the discussion in here. Ugh. Got 11 seconds. So what we're gonna do is we're going to take this tomato, apply it here, and we'll be back after a 5-minute break.
colorful pain.
And we're back. So, oh boy, Jan has tore up our design, which is great. So is Tom Jack. So what we're gonna have to do is we're gonna have to read and reply, and well, read, understand, and apply stuff. Now reading through TZIP stuff. Lots of comments and time. Like quality life. What better. Better. I'd like to use like interstitial in Rome. Like that's a thing that there's Twitter threads about how to get more out of Rome, like timestamps, like plugins that you have to use and stuff. But we'll tackle that some other time. For now, we just really need to stay focused on these comments. So let's go. That's behind the target branch. Interesting. Okay. All right. Where base 58 strings appear in Michelson so far, they are associated with the, quote, readable unparsing mode, and they have a corresponding optimized byte form. For example, push address KT1 blah, blah, is readable, but push address blah, 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 the optimized form. I'd expect something similar here. Tezos client mode mockup hash data foo of type string blah blah blah. So I'd expect constant Base 58 string will be 54 bytes. The overhead will be 2 bytes for prim. 4 bytes for the string length, so 60 bytes total. The bytes version will be 32 plus 2 plus 4. 38 bytes. That's about 2/3 size. 22 bytes saved. Okay, let's talk about. Let's parse what he's saying. So, this like expert thing. EXPR. Okay, the overhead will be 2 bytes for prim. Constant. 4 bytes for the string length. Alright. The base 58 string 4 bytes. I guess he's saying that a base 58 string is always 54 bytes, and then there's an extra 2 overhead bytes. Bytes version. (32) 2 for the constant, 4 for the string length, so 38. 2. Okay. I think I get it. Okay. We're gonna write like confirm. Like, you know, what am I trying to confirm? That like the base 58 string be 54 bytes. This thing. I'd like to confirm that like this thing is 54. I mean, he's saying it's 54 bytes. Like I'd just like to know like why this is bigger. Question. The question. Why is readable why is readable format bigger than optimized? I mean, like usually readable things are bigger than optimized versions of the same thing, but you know, I'd like to know exactly why in this concrete instance. But it's not important right now. We're just gonna trust Tom Jack. He's a smart guy. 38 bytes still seems relatively big. I think this means the idea will be most helpful for reducing storage space for rather large chunks of codes, say much bigger than 38 bytes, used in one or more contracts. Reducing origination op size, but not total storage space for large contracts by splitting entry points out. Maybe someday the idea could be combined with some local caching memoization in order to enable cheaper code/type reuse within a single contract. Theoretically, it could be possible to use only 38 plus n minus 1 bytes for n uses of a thing. We're willing to claim enough of the unused tag bit space, tags 11. Encode the hash once, Then for each use after that, you refer back to it with a single tag byte, say I28 plus I, referring back to the ith distinct constant hash referenced by the contract so far. Maybe one could use only min 38k by allowing to give the constant in line when it is smaller than 38 bytes. Okay, what we're gonna do is like this is helpful, but not gonna lie, it's a bit over my head right now. What we're gonna say is we're gonna GOTC, helpful ideas for reducing size and facilitating local caching in the future. We're just gonna add that there. From Jack. Great. Okay. Burning 3 prims, blah blah blah, and then making them semantically identical seems a bit unfortunate to me. Jan's gonna say the same thing. The status of these prims is also somewhat strange. First, they're in type prim, but they should never actually occur in any valid Michelson. I'm not sure if anything better could be done about this. Could it be feasible, for example, to type substitute like this? Type prim or constant. Prim of prim, constant of ... Second, the prims have been given almost meaningless type constant integer namespaces. The user may, of course, choose the namespace which reflects the usage, or not. But it seems a bit strange that behaviorally there is no difference. That you can have things like list constant, which appears to use the incorrect namespace, and that even constant is not actually a type. Constant is not actually an instruction, etc. If we must use a prim with a namespace, I think by just picking one constant, putting it either in a new namespace or maybe in the keyword k namespace. This is very reasonable. Okay, okay, I agree with this, and we're gonna come back to it. First, we're gonna read all of his stuff. Why? Easy. Michelson code golf to compensate. Oh, I'm just was code golf code golf. This is how do I explain code golf. Jan probably knows what code golf is, but I'm gonna just assume that he doesn't because I don't know how else to interpret the question. Code golf is a sport, is a programming sport where users compete to complete a programming task in the fewest characters possible. Somewhere someone compared the task of someone half jokingly compared the task of writing complex Michelson Michelson. Oh no, I haven't been streaming this whole time. Dang it. Okay. Complex Michelson compared the task of writing complex Michelson contracts to this sport. We're going to resolve this thread. And then we're going to talk about it. Okay. Where? Out to be. Oops. Why? Good. Toggle. Got a cache for a table. The cache and spire will on a table they are not. I don't know. What did I say? Like, let's like look at the code. Can we? View file. Where do I mention the word cache? Work. Sorry. This wasn't clear. I was not clear here. I am proposing a table. A table. The values in this table could later, be could enable more fine grained caching in the future, or even immediately with YY's work on caching. Like so. Users publish constants to the table. Constants are reused across many contracts, e.g. FA12 functions, etc. The values of constants of the most popular constants are held in some kind of cache, giving fast access to the parts of promoting and rewarding code reuse via the use of constants. I'm going to add this as a comment now. Um, I mean to say that if I understand unions work correctly, if I correctly understand unions work, then simply by using storage functors, the global table of constants will automatically get its own cache. Functors that storage function. So assuming assuming high levels of reuse for popular constants, this could, benefit, this so when a value gets looked up in the table, retrieved from storage, and added to cache, every other contract cache will be warm for every other contract using that constant. Oh, my foot's asleep. Okay. This looks like some arguments in favor. This item is not. This looks like some arguments in favor of the canon that are not related to the global. Oh, further. Oh. I'm not sure I understand. Let me try to explain clearly. Assume there is a function. Maybe some core function of the FA 1.2 standard, for example. We're good. We don't need to take the 5-minute break. We just had a pretty long break. Maybe some core functions of the FA2 standard. We will switch over to here, grab that tomato, put it on here. Oh, there we go. Excellent. All right, we've been working for 75 minutes on all this stuff. Keep rocking and rolling. Cache, blah, 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 blah. Okay. Assume that there's a function, maybe some core function in the FA2 standard that is extracted out into a constant. Suppose suppose we do some analysis later and find that this function is this constant consume that the retrieval what? Liberation interpretation of this constant function consumes some significant amount of gas. We could hard code a we could lower the function into OCaml and hard code we could lower the function into OCaml and like hard code like new instruction for it such that the constant gets replaced with this single instruction. It's similar to the idea of super instructions. But a shared table of constants with tracking, with fine-grained tracking of how those constants are used, gives us more domain level data. I assume there's a function, maybe some core function that is extracted out into a constant. Suppose we do some analysis later and find that the retrieval, elaboration, and interpretation of this constant function consumes a significant amount of gas. We could lower the function into OCaml and hard code a new instruction for it, such that the constant gets replaced with the single instruction during substitution. It's similar to the idea of super instructions, but a shared table of constants with fine-grained tracking of how those constants are used gives us more domain level data. I think that's okay. A new manager operation which allows the user to store a valid Michelin representative value. Requires a check that all references to existing contracts must be 4. Otherwise, cycle would be interesting. All right, audience. This is the big question. Is there any real problem with allowing global constants to refer to other global constants? Our concern is that, like, all right, let's write this down. Jan asks, like, problem. The problem is, oh, I'm not even sharing, am I? Here. The problem is billion laugh attack. Billion laughs attack. Okay. The idea is you create like a thing. Actually, this is the same idea as in the like OCaml exercises. Jan, I asked Jan like, how do I become a great programmer? And he was like, do these OCaml exercises. I think they're like, I don't know where they are. He sent me a link. Anyway, so like in them, like it has this like this trick problem. It's like you know, encode a certain function, but you can only, or like compute a certain value, but you can only use like 2 invocations of this specific function or something. So it basically like artificially constrains how many times you're allowed to call a function. You know, just teach you to think about like how that could be used to improve performance and just increase your overall cleverness and all of that stuff. Someday we're gonna like do a bunch of those exercises on this stream, and it's gonna be awesome. That's not today, or at least it's not right now. So this is the same idea as in those exercises. Let's look at the Wikipedia again. You know, you encode this entity LOL. You encode LOL1, and like it's a bunch of the same. So this each of these LOLs macro expands to LOL. That's fine. So, you know, this is like a one-to-one transformation. But then here, you encode this new entity. So each of these expands out to like what? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So like 10. And you do that like 10 times or 9 times, and now you've got like a billion LOLs in this very, very compact representation. And of course, like trying to parse a 3 gigabyte XML file is going to bork you. So we don't want that for Michelson. Because like, what if somebody is like, you could take down indexers that way. You know, someone says, what's the value of this constant expression? And you could, you could like encode a billion laughs Michelson expression by using constants that like, expand recursively. And yeah, so that's why we've included this check, like, hey, you aren't allowed to have recursive constants. But the downside is like, well, being able to recursively refer to constants would, increase the sharing. Like, let's say you have, you know, um, like, like, the function, f, and that's a constant. And then you have like, and it's something to do with like fa2. So, it's used all the time for like NFTs or something. And then you have the function, like f, like g after f, or is it f after g? I think it's g after f. Well, it would be nice if like g after f could look up f separately instead of having to store them both, because then you would only have to pay for like the g part instead of the whole thing g after f. I mean, yeah, it would increase sharing even further. The question is, can like, can you do bad things if we allow that? Same ideas in the general chemical exercise. Actually, I forgot which one. Definitely increase sharing. You could definitely decrease cost of publishing constant to just the change in storage. That's nice. The problem is billion laughs. You can't do billion laughs on the on like interpretation, because oh my goodness, there's so much noise. I live in a noisy neighborhood. Because we measure because we limit things with gas. But not every like tool consuming Michelson, like consuming data on the chain, is gas metered. Consider indexers. Could people do bad things with bad things to indexers with billion laugh contracts, billion laugh constants? Okay, and let's just we're gonna look up and see what Tom Jack said. Okay, we're gonna look up billion laughs in Slack. Okay, Archer says, because we instrument the expansion, the billion laugh is not an issue. Right. Getting gas right and things. My guess is that while a bad actor, so this is what I wrote like 2 weeks ago. Tom Jack, in a carbonated context, why do we still need to worry about billion laughs attack again? My guess is that while a bad actor could not use billion laughs as attack to slow down interpretation of contracts with everything in a gas, in practice, anything that touched contracts in a non-carbonated context, just like RC or indexers, could get mucked up generally. I'm implementing this trade in the latest table of constants in MAR to not allow storing Nicholson values that contain references to other constants based on our previous discussion. But I wanted to make sure that I had the reasoning right. Okay. Let's see what else Tom. Right. So thing there. All right. Okay. Even we're okay. We wrote we specified this the constraint that constants may not refer to other constants because we are concerned about bad actors implementing a billion laughs attack where, you know, they can encode where the size of a constant of a like fully substituted constant is potentially exponential to the storage price paid. Because, yeah, that's what we're worried about. The concern, while in theory the interpreter would run out of gas, interpreter would run out of gas on such bad constants, protecting the baking of blocks. We are worried about other tools that don't meter gas, like indexers. Maybe there is a way to have our cake and eat it too, but I'm open to suggestions. But for this first pass, I restricted, I forbid recursive constants for simplicity. DC at Tom Jack, who first pointed out the problem of billion laughs in this context. Okay. Oh gosh, I'm not recording yet. Man, I have to get like a macro or something, some kind of auto hotkey script to switch. This is getting ridiculous. We resolved that one. Okay. Again, with the complaining about like, hey, don't use 3 prims. All right, we're gonna ask my boss, like, yay. Tom, Jack, and Jan don't like that we used 3 primitives. Constant, constant, and three primitives. Constant. Was there a specific reason we did it this way? Or can I reduce to 1 as they suggest? Okay. I'm talking this one over with yay. See if talking this one over with the team. I don't even need to. I don't even need to say that. We'll get back to him. We'll skip it for now. Apply. Apply. Oops. Oh. Oh. Let's write this down. Jan suggests a GOC. Sure. Let's feature request. Call it like a just a request. Whoa. Subs shoot a contract in place so you can audit it, see audit it for correct. No. Maybe something like maybe add a command like Tezos and Hmm. Okay. Substitution. Apply substitutions to contract. Dot slash contract TZ. You know, and then like contract or at current block. Oops. Totally right. Okay, we're gonna have to edit. Ugh. Tired though, like alright, we've got a minute and a half. Okay. Here's the plan. Oh, let's go back here. Here's the plan, audience. We're going to take another 5-minute break. We're going to take another Pomodoro and we're going to like edit the TZIP to like all of the stuff. And then we're going to like reconsider this, like the algorithm that Jan wants us to implement. So like, well, technically, you know, our thing was like just respond. So maybe I'll just respond like, I will implement it as you say. And then, you know, we can create like a new little accomplice task for like refactoring the algorithm to be faster. So yeah, I think that's a great idea. All right, break starting now. And we are back. Okay. What are we doing now? When last we left off, going to okay. Yeah, so what we're gonna do is we're gonna now edit the TZIP MR itself, so that way the documentation is more clear, because Jan pointed out all sorts of, like, you know, in addition to grammatical problems like lack of clarities and all sorts of things. So first what we're gonna do is we're gonna go over to Realm. We're going to add Tom Tom I'm gonna say Tom Jack pretty epic name actually. Like the name of like a hero in a western. Tom Jack's sheriffs. I'm gonna stop now. Tom Jack says wait, has a feature request for TOC. Allow both optimized and readable addresses. So we can save bytes. Oh. Okay. Boom. Got it. So next, what we're going to do is we're going to go over to VS Code. We're going to C into the next directory. We're going to ls. Nope, it's not there. Okay, so we need to go to TZIP. Actually, we need to go to our fork of TZIP. So Marigold TZIP. Clone. Going to excuse me. Actually, what we're gonna do is clone the original. Git clone. Shit! I just spilled tea everywhere. BRB. Crisis averted. That was terrifying. We're also trying up standing desk mode. Cool. So, what were we even doing, man? Okay. Right. Okay. So what we should do, for the sake of like reporting, before we get too involved in this, we should like wrap up this, and then hit like done. So let's check to see what my boss said. Um, um, to, not sit here in silence with you guys, what I'm looking over is, I was like, hey, Tom Jack suggests we use the keyword thing. So let's actually go over here. Okay. What? Okay, let's go over here. Meaningless. We must have a prim with a namespace here. I think just picking one constant. It either in its new namespace. Oh. Oh, okay. Oh. Oh, his other suggestion was a new namespace. Maybe that's best. Yes, no? Yeah. Okay. Okay. All right, so while we're waiting on my boss for that, cache to, okay, we responded. Um, let's see, I'm let me sort out this detail with my team and get back to you. Okay, and where is his like algorithm? insane noise in my neighborhood. That's okay. One day we're gonna have our own house somewhere. No idea where. Okay. Oh, this is the thing on the TZIP. Okay, so have we addressed each of this? Okay. Finish. All right, this is okay. All we have to do, let's see, organize. We're gonna add some new actions for today. We're gonna say, 2, edit, TZIP. Oh, we're gonna say like, update TZIP based on MR comments. And we're gonna say, that's all I'm gonna commit to for now. Boom. My boss says adding a new namespace makes sense. So, what we're gonna say is, where's the TZIP? All right, burning through blah blah blah. All right. I'm not okay. I'm not really sure how to. You know what? Okay. This is getting complex enough that I should just start another Pomodoro timer and say, you know what? This is gonna take more. This is taking more time. Let's do it. I was hoping like it was just gonna, finish up, but like that's not gonna be the case. So let's do this. Okay. All right. I'm not really sure how to achieve this. Tried a few approaches and they all seemed really complex. I'll grant that it's inelegant. That it feels inelegant. However, semicolon. However, I'm not, however, I'm not really sure how to do this. Just something. You, if you want, I can spend some more time on this, or definitely feel free to suggest a better approach at YRG. Any ideas at YRG? Let me know. Okay. Okay, so we responded to that one. Great. Resolve. Okay. All right. So we've done everything except fix the TZIP. Okay. If I don't there like a way to like fix it in line? Oh, in MR. This will be so easy. Okay. Boom. Nine six two. 962. What? Oh, yeah. Apply suggestion. Apply. Great. All right. So we have addressed every comment on the TZIP. Now let's go over to the MR itself. Uh-oh. Ooh. Why on earth would this fail? I have no idea what the CI pipeline is failing, man. Like, no idea. All the time. We're not going to worry about it for now. We're going to stick to the task that we're doing, which is addressing all the comments. Okay. Let's read what I wrote here. I don't know where Jan is getting this. He's saying, do not understand why we want to reject registering a value with constants. It does not introduce cycles. Oh. With regard to 1A, okay, we'll go over to TZIP. Copy link. My attempt is to try to avoid a billion laughs attack. I left comments here and I would greatly appreciate your feedback. Perhaps we do not need to worry, but we will need to prove that this is the case. 1B. Agreed. I talked it over with my team, and we like at Tom Jack's suggestion of creating a new namespace allowing for a single structure. 1C. The Tezos client interface has to be specified. I've implemented the client interface. It is like this. I've what we're saying. Oh, gotta share it. Okay, I've now implemented the client interface. It is like this. Blah blah blah. Okay, and now let's print the thing. Okay, cd Tezos client register global constant. What do you mean? Unrecognized. I need to run make. So weird. If my T is. It's good. Oh, fell prey to it again. Hate that error. Global constant. So what's happened is it said failed to require the protocol version from the node. Okay, that's fine. But then it says unrecognized command. Try using the man command to get more information. That is the most misleading error message. But anyway, here's what Jan wants. So let's post it. Okay. Oh. Okay. Do this. 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 That'll do. Okay. And using the existing code origination as a guide, like this. C and 2. All right. We've addressed this thread. Great. Agreed. I will implement this. Sending their own name primitive prim namespace. With a single instruction, single okay. We're gonna resolve this actually. And we're gonna skip this one because this one's the most oops, I'm showing my screen. But we're gonna skip this one because it's the most complicated one. We're going to give a thumbs up. Oops. Thumbs up. Resolve and comment. Okay. Um good okay. Thank you for the suggestion. I will take a stab at implementing this and post back here. All right, every comment has been responded to, which means that we can check this off. Yeah, that's fine. That's great. Like automate scene switching with OBS. This would be cool to do. Like it's just like an AutoHotkey script. But as much as I want to do it, it's not the most important thing. So we're not going to do it right now. Because we're learning discipline. Okay. All right, so what's next? It's 4:31. Realistically, I could work like 6. Which means that we could fit in 3 more Pomodoros. Okay, so the challenge is, can we edit the TZIP inside like a Pomodoro? Like maybe. But first I'm gonna message Eduardo. Is he on Twitch? That would be cool. Offline. What about in Gathertown? Nope, he's not. Okay. Okay, so maybe I'll just send him a message being like, yo, time. Man, like I really have to learn how to like stop um like randomly browsing Slack. Like there's so much interesting discussion going on and everybody is so smart. But like uh I need to like partition that time. Like let's write this down. Working better. Like how to partition time reading all the amazing info generated in our Slack versus getting my tasks done. Obviously, it's important like to stay informed. Just as obviously, it's important to stay informed, but it's just as slash, but it's more important to do my tasks quickly and well. So yeah, we'll just have to figure it out. Working better, and then we're gonna annotate this with question. Question. Oh gee, what other questions do I have so far? What is the readable format bigger than optimized format? Like this is gonna suck. Figure out. Um, but that's okay. That's okay. Um, and I don't have a good clickbait title for the stream yet. So what are we gonna do now? Well, we're going to now that we've burned through majority of this Pomodoro, um, we're gonna update the TZIP MR. Okay, we're gonna cd into TZIP. Oh, we don't actually need to just we can now add it as a folder. Add folder. Zip. Load the code. Then we're gonna go into TZIP. We're gonna open up a new terminal. We're going to cd into TZIP. Git remote add marigold git at gitlab.com. And then marigold TZIP. Git fetch dash dash all. Perfect. Now we're going to git checkout h at table of constants. Great. Now we're going to get rebase master. Then we're going to get pull. Fine. Like that's honestly fine. It's just markdown files, so git history, I'm not super worried about it. we're going to go into drafts, current, draft, table of constants. And we're going to close all this stuff. And we're going to find the problems that we haven't addressed yet. Okay, so let's find find the thing. Here it is. Okay. And I feel like we just took a break. So we're gonna put this Pomodoro on respond to all the comments. So it took 125 minutes or about 2 hours. And keep chugging. Okay, motivation. Fixed. Unfortunately, the current size severely restricts the complexity of smart contracts, forcing users to resort to a kind of Michelson code golf to compensate. Our proposed solution to this problem is a shared table of Michelson values that contracts can reference by hash, allowing users to factor large chunks of code out of their contract. We expect the primary things to be factored out to be lambdas and large types. Factoring out lambdas and types has many benefits. Globally available lambdas form libraries of reusable logic, enabling much more complex applications to fit into the same size. Many contracts are bound to repeat code. A cache of the most commonly called functions could offer. Wait. Okay. Let's rephrase this. A table. Okay, a table of constants as the table becomes more widely adopted, it serves as a reference of the most frequently reused functions. This gives us fine-grained data to further optimize. Out of the box, we get caching of these values out of the box and combined with the work done for the carbonated storage cache. You can go even further. This gives us fine grained yields. This yields find. This supplies us with fine grained data to further optimize most heavily used contracts. Get caching of these values out of the box. this caching works with the table with a table of constants with a global table of constants. Caching works across contracts with similar logic as opposed to only the isolated per contract cache we have now. Wait, that's so unclear. All right, audience, help me explain this. So what I'm trying to say is, the Amazing Union has implemented a type of cache for the storage, so that like when you just you don't even have to change any of the code in Tezos, at least above the like he's had to change lots like in the bowels of it, but when you're using our APIs, like you make a call to storage and like it gets automatically thrown into a cache. That way you can retrieve it for less IO cost, less gas cost, et cetera, et cetera. So currently, the contracts, when they retrieve, their stuff from storage, contracts cannot share anything. There's no sharing of stored values in the cache. But if we switched over to like a global constant, so like maybe all the FA2 applications are hitting this global table of constants, then you can share those like the cache for it. So let's just try saying that in writing. Currently, there is no sharing of cached values between contracts. However, a global table of constants would allow such sharing. Enabling every contract benefit every contract that relies on a constant to benefit when a single contract warms that constant's cache. Sounds so clunky. Currently, there's no sharing of cached values between contracts. However, a global table of constants would allow for such sharing. Increasing the probability of a cache hit proportionally with how often a function is used. How about increasing the odds, because we want to be more informal? Like, I'm not going to talk about like probability theory here. Increasing the odds of a cache hit proportionally with how often a function is used. All right. we can go even further by replacing most frequently used constant lambda functions a value with camel code. Achieving native performance. This is similar to the idea of creating super instructions for the interpreter with the added benefit of unity directed like added benefit of richer domain data. That's not similar to the idea of creating super instructions for the interpreter. But in this case, we let the community direct us as to which function place with benefit okay. So the idea is like, alright, I think I already explained this in the stream, so I'm not going to explain it again. But with the added benefit of the community of community provided hints as to community, let's see, community driven hints, which function. Yeah. Okay. Okay, hopefully let's read this one more time. It's long, but we have to do it. As the table becomes more widely adopted, it serves as a reference to the most frequently reused functions. This supplies us with fine-grained data to further optimize most heavily used contracts. We get caching of these values out of the box in combination with the work done for blah blah blah. Currently, there is no sharing of cache values between contracts. However, a global table of constants will allow for such sharing. Would allow for such sharing, increasing the odds of a cache hit proportionally with how frequently a value is used globally. Allow. Okay, I think the idea is like, okay, so right now the cache is speeding up contracts in proportion to how often the contract is used. But the global table of constants provides like a finer grained, resolution. Oh, allows a finer resolution. can speed up contracts that reuse common values opposed to only speeding up contracts that use frequently used values that depend as opposed to only we can speed up all contracts that depend on frequency. So only the most frequently used contracts. Currently, there is no sharing of cache values between contracts. Period. A global table of constants gives us a finer resolution in the cache. We can speed up all contracts that depend on frequently used values as opposed to just the most frequently used. Those most frequently used. Only the contracts most frequently used, I think is how we're going to say that. Okay. We can go even further by replacing the most frequently used constant lambda functions with OCaml code, achieving native performance. This is similar to the idea of creating super instructions for the interpreter with the added benefit of community-driven hints as to which functions to place. Large types for complex storages or parameters are often repeated throughout a contract, taking up precious space. Referencing these types via constants alleviates this problem. Okay. A new manager operation, blah, blah, blah. Storage table is implemented. We're going to change this. We're going to say a new Michelson primitive is added for referencing these values. When applying a transaction right before type library, we substitute no value is found, the transaction type, no knowledge, the Michelson type letter interpreter do not change in any way. Okay, great. That was actually pretty easy. How much time do we have? We have like 11 minutes left. Awesome. Running 3 and making them all smooth. Da, da, da. Oh. 3, blah, 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 blah. Should make sure. So I'm gonna call this okay for now. Like In retrospect, you should have started with the client commands. I'm writing that down. In retrospect, should have started the client commands because like that's like it's like when you're creating a website, you use a mockup tool because it's super easy to show your investors or whatever, like, oh, this is what it's going to look like approximately, and they're like, oh, you're missing this feature, or you don't need that other feature, and like it's super easy, and I wasted so much time by like not starting at that top layer and like working my way down. I went from bottom up instead of top down. I know better. Uh, I know better than to start bottom up. Um, but like the thing is, I didn't really understand how the client code worked. So I was kind of intimidated to start there. So now I know. Now I know. Um, I can think of it using a mockup tool. Mockup tool when designing website. It allows for really clear communication about the intent of the thing. Yeah. Yeah. Like, I'll just be honest. Where's that sucker? Client. Yeah. Man, I saw stuff like this. I was like, nope. We're working on something else. But boss is always telling me, like, oh, you have to go depth first because this stuff is really hard to understand and it's really hard to kind of, you know, um, build a correct model in your head, out of abstractions. Um, there's surprises around every corner. So, using generalizations or abstractions often gets you into trouble. At least, that's been the experience. Um, so, uh, yeah, lesson learned. Next time, we're going to start with some client commands and we're going to like mock them out so that it's easy to see. And then we're going to like, implement them as well as we can. Okay. All right, what's the difference in my terminology between like an insight? Like, I want to have like a distinction between a lesson learned, insight. These are spur of the moment and may or may not be may or may not reflect absolute truth. Truth, wisdom. Nonetheless, probably good to go back and reflect on now and then. So that's how I'm defining an insight. It's like light bulb moment. Not every light bulb moment is true. But we're going to write down our light bulb moments and revisit them. Now we've merged lessons learned and insight. Great. Okay, like applying just from comments like that. I'll just that and great. So that means that this is done. Now we've got an hour left or so. Online. Buddy. See who's in gather. Us. Let's hang out and gather. Yeah. Yeah, we're hanging out and gather now. No. Figure this all out. Anyway. This is our virtual office. I'll pretend to co-work together. It's pretty sweet. There's my virtual avatar. About the only similarity is blonde glasses. But what else do you need to know about me? So okay. Let's check out Jan's algorithm and see if we Let's read it one more time. Given that the value you are substituting into can be large, think that we can try not to iterate over it using a monadic computation for the sake of efficiency. Instead, probably decompose the process into 3 steps. Iterate over the value to retrieve all constants it uses. Write this outside the monad. Put the constants in a set to avoid repetition. Okay. Like that actually sounds pretty easy. Fold over the set of constants, build a hash map from constant hashes, values in the monad. Apply the substitution outside of the monad. Okay. I had to read it a couple times, but this is actually super clear. And I think I'm going to be able to implement it. But after the break. So I have like 1.5 minutes before it will let me like drag this thing. So we'll use that, get set up, and then we'll come back and implement it. Like it would be cool to like benchmark before and after actually. Like it'd make for a more exciting stream, certainly. We're gonna do it that way. We're gonna do it that way. I wonder if Chum Jack is around. Okay. Accomplished a ton in this stream. And by a ton, I mean exactly like 2 things. We responded to comments and uh you know, that's all we did. We just but it's still been fun. We've learned a lot. It's a lot of progress. So we're gonna wrap up this stream. I'll catch you in a few minutes for stream.